Hello, everyone, and welcome back to the FUNWAVE application on the HPC Portal. We're still working through the third tab of our simulation workflow, this Inputs Outputs tab, this time focusing on the breakwater and obstacle fields within this tab. And here you will add and define any obstacles and/or partially or fully reflective breakwaters or other similar coastal features in your domain. Now, this will be a relatively quick tutorial. This is the 7th video in our FUNWAVE application video tutorial series. Be sure to check out the previous videos in this series if you haven't already. As always, tune into the FUNWAVE comprehensive wiki page to learn more about the model and its input parameters. In general, there are 3 ways to implement a coastal feature or obstacle in your numerical domain in FUNWAVE. The first is a direct modification of your bathymetry or depth file. This would be considered an impermeable feature in your domain. The other 2 options are an obstacle file or a breakwater file. An obstacle file is essentially an infinitely tall wall that cannot be penetrated, acting as an impermeable, fully reflective feature in your domain. So if you do have the desire to put an obstacle in your simulation, you can check this box, and then you'll be prompted to upload an obstacle file. So similar to your frictional matrix or your depth file, this file will be an ASCII type file that has the same dimensions as your grid size. Now, what goes into the obstacle file is just ones and zeros. The ones and zeros define where there is a natural part of the topography and bathymetry, or where there is an impenetrable obstacle. So ones will represent the natural features, almost like a translucent section over your depth file. It would ones specify exactly your depth file to an extent. And zeros define the location of this obstacle or represent, an opaque area over your depth file that would be representative of this infinitely tall, fully reflective wall. Now, if we do hover over the info icon, we can check out the Wiki for more information. And this would go into more detail about those different options of adding coastal features, as well as the specifics of the breakwater and obstacle files. So let's just go to the Wiki here. And we can scroll down to the obstacle file field. So we can see more information on what goes on in the obstacle file. This section essentially covers everything that I just mentioned, that the file has the same dimensions as your grid, and that ones are non-obstacle points and zeros are obstacle points. And recall, obstacle points are these permanent dry points with full reflection, meaning nothing goes through it, nothing gets reflected, refracted, diffracted, and so forth. So let's jump back to the FUNWAVE portal. So again, if I check this breakwater box, a similar process occurs. You again will be prompted to upload a breakwater file, which again has the same dimensions as your grid. But we also have this additional variable that comes up, this breakwater absorption coefficient, and we see that it has a default value of 10. So to give you a better explanation of how the breakwater file is set up, what goes into the breakwater file, and what this variable means, let's go back to the wiki. We already have it open here, so we'll just jump back to it and review these fields. Now, the important part here of the breakwater file is that non-zero values indicate the location and width of this dissipative frictional sponge layer internal in the domain. So this would be representative essentially of a permeable feature in your domain that acts as a frictional dissipator to the incoming wave field. This functionality could present or represent essentially a partially submerged or porous coastal feature, for example. Now, opposite from the obstacle file, zero values designate non-breakwater points versus in an obstacle file, zero values designate the obstacle points. while in the breakwater file, non-zero values specify that width of this internal sponge layer. So when you're thinking about putting an internal sponge layer or putting this breakwater file in your domain, you want to think about its location, but also the width of this sponge layer at that location. The width is specified in meters. So non-zero points will typically be a value greater than 10, for example, representing a sponge layer with a width of 10 meters at that desired location. And so on the wiki, we have a little bit more description about what sort of absorption comes from a particular width that we've seen. And you can review that here. And so lastly, let's jump to this breakwater absorption coefficient variable. Now this variable is the value of the maximum CD parameter, or that coefficient of friction, in the bottom friction formulation. The default value does start at 10, and this might be something you want to tweak or tune in terms of calibrating your simulation, depending on what types of waves you're using, whether they're spectral waves versus regular waves, and what kind of wave response that you're investigating in your simulation. These numbers may need to be bigger or smaller depending on those considerations. Now, there is a note down here letting you know that for larger waves where the significant wave height is certainly 10 meters or bigger, a larger parameter can cause imbalance in the momentum equation. So something to keep in mind if you're really pushing the limit, you may want to use a smaller parameter to avoid this imbalance. Otherwise, this is generally something not to worry about. So overall, on this breakwater and obstacle page of the FUNWAVE Wiki, we have a lot of answers or details with regards to how to implement such features in your numerical domain and what they may represent physically to your physical conditions. So jumping back to the portal, we can uncheck this and make sure to save any work or changes that we made on this tab. And this will conclude our tutorial on the breakwater and obstacle field of this inputs tab. We do hope that this was helpful. And if you do have any questions, again, double check that wiki or contact us via email. Happy modeling.